After each group finished preparation of samples and sent the sample to the laboratory, while waiting for the measurement, each group had learned how to fit spectrum. Now you already know how to fit spectrum and ready to analyze data. In this video clip, we will introduce you how to prepare final report. The report form will be sent to your email or you can download from the website. You have to click on your group. On the group page, you can find your status from the beginning until now. Also include the next what you have to do until finish. At the end of the page, you can find the documents for download. You have to select Final Report Form and download it. After download, you have to open. The report form is prepared in spreadsheet. You can use with Excel application. The first part, in the green boxes, you have to fill the information of your group. First, group number, and then the row size where you collected the sample. If you don't remember, just have a look on your website. In the tables, you have to fill the results of fitting from every sample. Every research site has code. For example, at the right-hand side, there is a code of 0AR, and you have to match the name of data file of the sample at the site 0AR. By looking at the page of your group, 0AR, the file name is Pircha-Prufka. You have to record the name of data file at site 0AR. Next, you have to analyze data. So have a look at the page of Analyze Data and Write Report. In this page, describes you how to write final report. If you want to save time, you can watch from video clip. In order to analyze data, you need to use 3fit software. So click on 3fit software, which you have learned already how to fit it. Select the file Pircha-Prufka and download file. Grab it. In order to fit the background, we select the range from 4 to 15. In this range, the background is linear. Next, you have to fit the background. If you think it's good enough, you have to record the height of background and slope. Next, you have to fit the peak of chemical elements. There are 10 chemical elements to be fit: iron, nickel, copper, zinc, gallium, arsenic, bromine, rubidium, cesium, and lead. After fitting of a peak, area under the Gaussian curve will be calculated. The chemical elements are normalized with respect to gallium. In the process of sample preparation, the lab scientists put gallium as the internal standard. So we will normalize all chemical elements with respect to gallium. But in some groups, the lab scientists didn't put gallium. In this case, you have to normalize with respect to copper. And altogether, you have to fit 9 chemical elements except gallium. In this example, we could start from peak of gallium is located around 9.25 kilo electron volt. So we will go to the peak of gallium. It is the peak of gallium. We have to make the benefit of this peak. Alright, we have to record the result and enter. Now we have the area under the Gaussian curve of gallium around 2756. The normalized of this number with respect to its area is equal to 1. If we have a look on the graph, you can see the level of gallium now equal to 1. Next, we will fit the peak of iron. The peak of iron is at around 6.4. 6.4 is here, and we have to make the bedwidth. If you think your Gaussian curve will fit to the peak, next we have to record the result. And now you got area under the curve of iron and normalized with respect to gallium. On the graph, you will see the level of iron, which is lower than gallium. Next, you have to fit other peaks of this spectrum. After that, you have to finish fitting of every. When you finish filling the report form, on the first page of the form, you will have the table of data and graphs representing the level of each chemical element in each sample. Be careful. Every time you finish fitting and record the data, don't forget to save your file. After that, you have to analyze data and put in the second page. You have to make conclusion of your experiment on the third page. In the next video clips, we will talk about how to plot graphs of distribution of chemical elements at the different distances from the root edge. See you.